Page 192. Oh shoot, I forgot which one I'm doing. Hold on a minute. I'm doing 49 and 51. Alright, so here's 49. It says y equals x to the natural log of x power. Okay, so what we have is an expression where we have a variable in our exponent. And this is not e to the x, it's x to this thing with a variable. Okay, so we have to do the little funky natural log thing. So we get the natural log of y equals the natural log of x to the natural log of x power. Okay, and then our rules of logarithms say if you're taking a natural log of something and it has an exponent, you can bring that exponent forward. Isn't this a lovely color? This is just pleasing to the eye. It's like a pleasant mathematical Easter egg hunt. So that exponent comes forward, and you got natural log of x in front of natural log of x. Well, that's kind of funky. All right, here's what I would do if I were you to make your life easier. That happens to be, in parentheses, natural log of x squared. And you got to put it in parentheses because it's the natural log that you're squaring. All right, so that just seems like, I think that's going to make it easier. That way I don't have to do product rule. I can just do the chain rule. Okay, the left side we get 1 over y dy. The right side we do our regular derivative rules, bring the 2 forward. So we get 2 times natural log of x. And it goes down to natural log of x to the first, so I don't really even need those parentheses. Times the derivative of what's inside. And what's inside is this little natural log. So when I do the derivative, I get 1 over x. The derivative of x is 1. So all I have now is that little dx portion. So 1 over y dy equals... Okay, so putting it all together, you have 2 times the natural log of x over x times your little dx. Multiply both sides by y. Oops, I put dy, but I meant dx. And then you substitute the definition for y back where it was. So you have 2 times the natural log of x over x times whatever y was, which is x to the natural log of x power. So altogether, that gives you 2x to the natural log of x power times the natural log of x all over x. I think that's probably the best way to leave it. I mean, the only thing you could do is combine those x terms, but I don't know that that's really going to help you much. Well, let's just show you what it might be, because part of the problem is being able to check your answer in the back of the book and knowing how they got what they got. Okay, so the only thing, again, that I notice there's no addition or subtraction, okay? So I have both of these things with x as a base. I have x to the natural log of x power on top, and I have x to the first on the bottom. Your rules of exponents say you can just subtract exponents. Okay, and when I subtract exponents, I get x to the natural log of x minus 1 power, right? Because you have natural log of x minus this 1, that's your exponent, times natural log of x. So that's the only other way, and then that's dx. That you might see the derivative for that. I think this is a perfectly fine answer if you had that in the beginning. All right, so that was number 49.